Hi, my name is Jason, and this is my assignment 4 for the Comp 3132. And here we go. So this first block, of course, we have all the imports that I have, TensorFlow. We're going to use the image data generator, MP, plot, all of this, and also the CIFAR10 data. That's what I decided to use. And we're going to go through it. So here we have the data preparation where we're just essentially loading the data and also just changing the, I could say, raw data from the ranges 0 to 255 to the 0 and 1 just to make the model's life easier to read. And here I'm just showing just the sample just to make sure that's working. So, I did an X-train to the second data. Here is just showing, the range from 0 to 1. Go down here, we're just showing that image here, just make sure that, it's working out perfectly. Going on here, we have the training with the test splits and all that. So essentially, the test size is going to be 20%, the training is going to be 80%. So after that, we have the augmentation. So we're going to use the data generator and the image data generator. So essentially, this is just transforming the data into a new variation of it. So, how much you want the data to randomly rotate, how much you want it to shift a certain direction, if you want the image to flip, in a certain direction. Here is just where we're transforming that data. Then we go into training the model for, we're going to show the over parameterization to cause the overfitting. I want to demonstrate that. So of course we have the convolutional layers, with the max pooling. Then we have the flatten with the dense, with the neurons being high, so we can show the overfitting. Of course, we compiled the model, and here we're just showing the number of epochs and metrics. So of course, we're going to go down here. We're just showing the accuracy, as the epoch goes up, the accuracy as well goes up. But these are insanely high accuracy. But if we go into the plot, here we're seeing the train accuracy, skyrocketed to past 90%. But the actual validation accuracy, it plateaued around 60%. So obviously, this is showing a huge, gap. And it's showing that the train accuracy is higher, which is obviously a sign of overfitting. Of course, the same functionality with the loss, where the validation loss is it started going low, but it actually skyrocketed. So it's just telling us that it's memorizing the training data, but it's not generalizing for unseen data, essentially. So here I've incorporated the dropout, where it's essentially the same model, but of course we have the dropout layer here. Essentially it's gonna just dispense like a random amount, about 50%. So of course we're gonna have, the compiling here. Sorry, we're gonna have the history, defined here, as well as the epoch running. So we show it on the graph here based off this. Now, the accuracy for both are slightly more, I should say, what's the word I'm looking for? Slightly more accurate in terms of not being too far apart from each other compared to the accuracy we've seen with the overfitting. So the accuracy definitely has taken a hit, but in terms of the gap between accuracy are now smaller. So the validation accuracy plateaus around 60 to 65%, but the training accuracy is around 55%, let's say around that. So obviously, the accuracy could be higher, but we gotten the overfitting to be less now. So there's not too much overfitting compared to the previous model that we've seen before. So now we're gonna go into all the same functionality with the model. So now the model is actually learning, what it needs to learn in order to, use this for unseen data. But obviously the gap is still there. But it's not as crazy as the previous plot that we've seen with the overfitting loss. So here we have the L2 regularization. That's the other one I decided to use, the other technique I decided to use in order to essentially eliminate the overfitting, plus with the dropout still intact. So essentially I'm just combining the two in a way. And here, as we ran that, we have the, the history as well as the epoch, and that ran as well. And we look on the plot here, we see that is essentially neck and neck. Like there's no signs of overfitting. Both plateaus around 65%, which is, obviously the accuracy, you want it to be just a little bit more higher, but in terms of overfitting, there's no signs of overfitting here. So essentially, we eliminated the overfitting issue with the dropout and the L2. So it's the same thing for the loss here. We have essentially the same thing where we eliminated the overfitting. So now essentially it's neck and neck. You know, it basically learns new data and it's not just memorizing the training data. Now, if we apply this to new data, or the model applied this to new data, it's able to predict accurately, and is able to make a good guesstimation. Sorry, it's able to produce a new prediction, essentially, for the unseen data instead of just relying on the training data. It's able to actually learn the patterns and learn all the complex patterns and learn the rhythms that it needs to learn in order to apply itself, so we can get a good estimation on the new information. So that is essentially my assignment 4. I appreciate you for listening. And yeah.